Okay, if you're like me, you like to move your camera around. I know I do. But the problem is, how do you move your camera around in some way that's sort of cinematic, but tracks the player maybe, but doesn't wind up wandering off the side of the screen, all that kind of stuff. So let's take a look at that. I'm going to do it in Bolt, but all these concepts, of course, could be used in C# or any other kind of thing. So let's take a look. All right, so what we're going for is this. Let's see how quickly we can do this. I have just this wheel, which is representing the player here, and I have a simple kind of WASD kind of control, and you'll see it's kind of moving around, and it hits the end, it gets towards the end, and you'll see that it the camera basically tracks it until it gets to this point where it's not allowed to move beyond, right? Now, the other cool thing is you'll notice here it moves a little bit up and down, but over here, where there's this wider area, it can move a lot more up and down, okay? So how do you do that? Okay, how do we do that? All right, well, it's not incredibly difficult. It just requires some planning. All right, so basically, if we take a look over here, here's what we're gonna go from. Now, so over here in our scene, you can see we have the area, and there's enough tiles around just to keep it on the screen. It's not infinite, and that's the world that we want to stay within. Now, you'll also notice that the camera over here only gets to the end of that. You never saw any blank areas. So how do we do that? How do we limit that? And it happens to be, I've left these boxes out here just to sort of indicate what's going on, to give you a little hint so you can sort of follow. So if I look here, I have camera bounds 1, which is set here, and I have camera bounds over here as well. Now, if I move the camera within those boundaries, you'll see it stays on the screen, right? So I have these two boxes which have box colliders on them, which are set up to be triggers, right? So what's going to happen is the camera is going to be moving within those areas, right? The camera is allowed to move within these areas, okay? So if we hit play again, you'll see, come on. So the camera goes over here. Now the camera, once it's in there, it is allowed to move within that area, and you see it snaps over there if it manages to get its way out, because it's tracking the player, but it can't exit those boundaries. Now, if I wanted, I could even do this. I could say, oh, okay, let me add another camera boundary. I'll say Control D, and I'm gonna make this one, let's see, we'll say edit this. Well, first off, let's move it, say down here, and we want it to overlap with the other boundary just a little bit, and edit that, and we'll make it move here and go down. So once we hit this, we're allowed to travel within that box. Ready? Let's hope that works. All right, so we move here, we move down, and sure enough, the camera is allowed to follow that until it runs out of space. You'll see it'll let the, eventually it'll come back and snap in. All right, so what's the magic? How does that happen? Now, I'm gonna assume that you're sort of familiar with collisions, because collisions is an important part of this. And I'm gonna try to zoom this in a little bit here. It's tricky. Sometimes Bolt definitely can be a little bit overwhelming on the screen. You like to have a nice big screen for using Bolt. So in Bolt, we have a couple things going on. Now, first off, I have the main sort of camera tracker over here. And so during update, the camera is going to basically interpolate between the position of itself, right? So here's a lerp, and it's interpolating between itself and some new position. Okay, so I have transform get self, and I have this new position, and I'm using lerp. And I'm just setting a time value of 0.1. I'm doing a poor man's lerping here, right? So it's just saying, okay, move basically 10% of the way towards that target. Okay, so it's not timed, it's basically 10% of the way towards there. It's kind of Zeno's paradox kind of thing. And then it sets that here, all right? So question is, what is this new value that we're going to target for? Now, the simple thing to do would be to say, okay, let's get the position of this target. Now, what the target is set to be a variable. We're getting a variable. This is an object variable. So if I come over here and I click on camera, we will see that there are variables set up here, and these are object variables, and the player is the target. All right? So we get the player, we get the player's position, we expose that vector 3, so we have an X and a Y, and that's going to be the new target. And we're going to create, now if I didn't have this section here yet, I would just use this X here, this Y here, and hard code this -10, because that's where I know that the camera wants to be on that plane, that -10 plane. And that would basically interpolate between this player's position and the target here. All right? The camera's position and the player's position. Right? So again, get the camera position, get the player's position, turn it into a new vector with the same plane as the camera, interpolate it, and move. All right. Now, this is where the magic comes in, where we set the boundaries. Now, so what I do, in order to set the boundaries, I set up colliders. And my colliders are actually triggers, right? So I'm going to use those as, once you enter one of those triggers, it uses the boundaries of the trigger to, kind of constrain the motion, right? So now I've got this on trigger enter 2D. So when you enter a trigger zone, it's going to set this bounds variable. Now, bounds variable has a center and it has extents. Now, by default, this is just a object variable that I set up called bounds, right? And it is going to be just a local object sort of variable here, so I can refer back to it again. So when I enter a zone, I expose the collider so I can figure out, okay, what did I collide with, get the bounds of that collider, and set my local variable to that. So I'm going to keep a copy of those boundaries of the collider. All right? Now, once I know that, this is where this magic is coming in, where what I'm doing is I'm saying, all right, instead of just interpolating the new position of the player, I'm going to clamp that to those boundaries, the boundary of the collider. So I pull the boundary here, that local or object variable, I expose it so I can see, okay, what it's going to do some translations here, or some, not translation training, but some conversions here to give me the minimum value that comes here and the maximum value of that collision area. And since it's a rectangle, it just is basically the corners, right? So I get a minimum value for X and Y and a maximum value for X and Y. And then I just plug those in to the minimum and maximum for these clamp values, right? So what clamp does is says, okay, passes in a value and makes sure that that value is between the minimum and the minimum and maximum, right? So this one's taking care of X, this one's taking care of Y, clamps those, and then that is the new value to use here, right? So anytime we enter one of those zones, it's going to assume the zone that we're entering is the new boundary. It sets the new boundaries for the camera. Now, you certainly could do exactly the same thing for the player, right? And you could have player boundaries that did the same thing. So basically say, okay, you're allowed to move the player so long as it's within those boundaries. Now, the case of the player, you might want to do that with traditional colliders and physics and so on, because, well, you know, maybe you're using physics to control the player, and that's going to be. But if you're just using a straight translation, you certainly could use this same method, right? So it's real simple. Interpolating a new position for the camera based on the player, but clamped to the boundaries of the most recent trigger or collider that the camera bumped into. All right, hopefully that was useful. About 10 minutes. It's going to give a pretty sophisticated look to your game, so I think it's worth the 10 minutes. Again, if you're more a C# programmer, give it a try. Certainly, you can do these same sorts of things. You may not be familiar with the bounds fields within some of the classes or components, but you can expose those just like any normal ones. So give it a try. Let me know. Hope you enjoyed it.